Here's a simple geometry problem. Look at this triangle. You're told that the left side and the right side are exactly the same length. Now prove that the two bottom angles are exactly equal. Stare at it for a moment, and it feels impossible. There just isn't enough information. But humans have a secret weapon: creative intuition. What if we split the triangle in two? Draw one line from the top point straight down to the midpoint of the base, and something magical happens. Suddenly you're looking at two smaller triangles, side by side with the exact same side lengths. They're congruent, perfect identical twins. And if they're identical, the two bottom angles have to be equal. Problem solved. Now rewind, and watch what your brain just did. You searched for a pattern. You imagined a few random lines, felt they were going nowhere, and threw them away. Then one idea clicked. Connect the top to the midpoint. You tested it, and it worked. Try, reject, solve. You reach the destination almost without noticing the journey. That extra line has a name. Mathematicians call it an auxiliary construction, and for us, drawing it feels effortless. For computers, it was a brick wall for decades. Give a machine an algebra problem and it crunches the numbers instantly. But geometry demands a flash of visual creativity. There are infinite places to draw a line on a page. A traditional computer, testing every single one, would simply freeze. And yet humans do it effortlessly. The gold medalists of the International Mathematical Olympiad can stare into terrifyingly complex geometric mazes and just feel where the missing line belongs. For years, scientists believed this artistic intuition was something exclusively human, until 2024, when Google DeepMind built AlphaGeometry. AlphaGeometry doesn't think like a calculator. It runs on a dual brain system that mirrors the way we solve problems. On one side is the fast brain, a language model, like the AI you chat with every day. It doesn't know the rigid rules of math, but it has incredible instincts. It looks at a puzzle and says, based on everything I've seen. His feet a line right down the middle usually works. It provides the creative spark. On the other side is the slow brain, a symbolic logic engine, strict, rigid, purely logical. It takes every creative guess from the fast brain and checks it against the unbreakable laws of geometry. If the line leads nowhere, it's rejected. If it builds toward a proof, it's locked in. The imagination of a writer, paired with the precision of a programmer, that combination cracked the code. But there was one massive catch. AI needs data, and the world simply doesn't contain enough written, step-by-step geometry proofs to train on. So the creators did something wild. They made the AI generate its own. A computer produced 100 million random geometric diagrams, then worked backward looking at each figure, deriving what must be true about it, and writing its own perfectly clean proof. A synthetic training ground, built from thin air. And by practicing on millions of self-made puzzles, the AI grew something no machine had before: artificial mathematical intuition. Then came the test, 30 geometry problems from past Olympiads. The results shocked the academic world. Previous AI systems could solve about 10. An average human gold medalist solves around 26. AlphaGeometry solved 25 out of 30, performing at the level of the sharpest high school minds on the planet, entirely on its own, inside strict competition time limits. And this was never just about triangles. AlphaGeometry proved that AI can cross the bridge from recognizing patterns to genuine creative reasoning. The boundary between human intuition and machine intelligence is fading faster than we ever imagined, and the future of science will never be the same. That's all for today on Dots and Arrows. See you in the next one.